All right, we're going to try recording some more video notes here and try to do the two tests in 10.5 using my phone to record this, so hopefully everything works out all right. I'm going to do two tests here, the ratio test and the root test. This video will be a focus on the ratio test. This one is easy to confuse when you're first starting with the limit comparison test because you can see there's a limit involved, but this is very different. This is just a single series. So here we're focusing on an infinite series with positive terms, and we're letting r equal the limit as n goes to infinity of the ratio of the n plus first term over the nth term. So there are three possible conclusions here. If that r is less than 1, the series converges. It sounds familiar. If the r is greater than 1, or that limit as n goes to infinity, a sub n plus 1 over a sub n diverges, then you can guess what's going to happen here. The series diverges. And finally, the bad news, if that r is equal to 1, this test fails. And you can't actually use it. You need to find another test. All right, so let's do some examples. I think we have 3 or 4 examples here. Determine the convergence or divergence of this series. So a sub n is 2 to the n over n factorial. A sub n plus 1 would be 2 to the n plus 1 over n plus 1 factorial. So we want to find the limit as n goes to infinity of a sub n plus 1 over a sub n. So that's the limit as n goes to infinity of 2 to the n plus 1 over n plus 1 factorial all over 2 to the n over n factorial. And in the end, what ends up always happening on these is you end up multiplying by the reciprocal of the a sub n. So that's 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 to the n. And let's see here, 2 to the n plus 1 is really 2 to the n times 2, right? N factorial over 2 to the n. And then n plus 1 factorial, n plus 1 factorial is n plus 1 times n minus 1 times etc. all the way down to 3 times 2 times 1. And so that is really n plus 1 times n factorial. So when we simplify, these all become 1. We end up with the limit as n goes to infinity of 2 over n plus 1, which is 0. And that is less than 1. Therefore, the series n goes from 0 to infinity, 2 to the n over n factorial, converges by the ratio test. If you really want to practice here, example 2, this would be good to pause the video and try on your own. I'm going to go ahead and do this one. A sub n is n squared over 2 to the n. A sub n plus 1 is n plus 1 squared over 2 to the n plus 1. All right, so we want to do the limit as n goes to infinity, a sub n plus 1 over a sub n. And that's the limit as n goes to infinity, n plus 1 squared over 2 to the n plus 1. And again, you're dividing by a sub n, which in the end means you're multiplying by the reciprocal. All right, that's the limit as n goes to infinity. Again, 2 to the n plus 1 and 2 to the n, that's going to simplify and leave a single 2 in the first denominator. N plus 1 squared over n squared, let me just write this as, maybe you'll just do this, n plus 1 over n squared. And then there's a 1/2 here because of this 1/2. So the n plus 1 over n squared, I mean, if you wanted to multiply that out, that would be n squared plus 2n plus 1 over n squared, and the limit as n goes to infinity is 1. So this is equal to 1/2 times 1, which is 1/2, which again is less than 1. And so the same conclusion, therefore, the sum n goes from 1 to infinity, n squared over 2 to the n converges by the ratio test. Right. And we have one more here. You might have in mind other ways to prove the convergence or divergence of this series. That is good. There are certainly other options, but let's try proving this with the ratio test first. That's why it's here. That would be n plus 1 over n plus 1 squared plus 1. Let me simplify that denominator, n plus 1 over n squared plus 2n plus 1 plus 1. So it's n plus 1 all over n squared plus 2n plus 2. So we do the limit as n goes to infinity, a sub n plus 1 over a sub n. So that's the limit as n goes to infinity, n plus 1 over n squared plus 2n plus 2 times the reciprocal of a sub n, n squared plus 1 over n. And that gets me the limit as n goes to infinity. I think I'm just going to multiply all this out. We'll have n cubed plus n squared plus n plus 1 all over n cubed plus 2n squared plus 2n, and that limit is equal to 1. That's bad news. So the ratio test fails. We can't conclude anything. Why don't you pause if you don't have something in mind and think about a different test that could work here to prove the divergence or convergence of this series. And what I would do here is, if you notice n over n squared plus 1, the 1 really isn't relevant as n goes to infinity, so it's n over n squared, which is 1 over n. And we know that series diverges. It's the harmonic. Unfortunately, with the plus 1, it's going to be under a divergent series, so we can't use direct comparison, but we can use the limit comparison. Limit as n goes to infinity, n over n squared plus 1 over 1 over n. That's the limit as n goes to infinity. N over n squared plus 1 times 1 over n. No, times n over 1. Sorry, reciprocal, right? That's the limit as n goes to infinity of n squared over n squared plus 1, which is 1. And this one, the 1 is okay. In the limit comparison test, we just want to get a limit. We want it to exist, and we want it to be greater than 0. This is greater than 0. So therefore, our series, there's like big trucks coming by. I don't know if the audio picked that up. That was like really loud. This one also converges by the limit comparison test. So that is the ratio test. The next video we will do the root test.